day 12 of the Cyber Advent 2024. I know it's already January 2nd and this is over by now, but we have access to these challenges for the whole year. 31st, congratulations. I hope you do win one of the prizes out there. I'm hoping I will win one of those too. I'm Aaron, aka Cyber Sensei Aaron, into it. So today looks like we're going to be doing a race. So we'll go ahead and read some of this story here. Warville's bank had a huge turnover this year and expected a massive profit before the holiday season. They were eager to disclose this news to the townspeople during the Sockmas celebrations. However, to their surprise, things went the other way around. After completing the annual calculations, the accountants were shocked to see a considerable loss. They observed discrepancies in the account balances. The bank called McSkitty to help investigate these users' fraudulent transactions. Upon analyzing the bank's website transactional logs, McSkitty found some interesting transactions. Few users, including the mayor's team, initiated multiple transactions from Warville's reserve accounts at once. Surprisingly, all these transactions succeeded, despite exceeding the user's current balance. Glitch was already aware of the critical vulnerability allowing these fraudulent transactions that Mayor Malware and his alliances exploited. Looks like Mayor Malware robbed the Bank of Warville and pretty much stole everyone's money. So let's dive into how exactly he did that. So today we're going to be learning about race condition vulnerabilities, how they work, what they are, that kind of thing. We're going to identify some gaps in HTTP2 protocol, then we're going to exploit the race conditions, and then we're going to learn how to fix the race conditions as well. So we're just going to need the attack box and the VM today. So if you haven't already started up here, and then you can start your attack box by going up here. There'll be a button that'll say start attack box. Wait till those load up, and then we can head to the link here. So let's dive into web timing and race conditions here. So in a nutshell, what race conditions are is essentially this happens in multi-threaded applications a lot of the time. And essentially what happens is you're sending two concurrent requests at the same time. And then depending on how the application handles those requests, whether it processes them as they come in or processes them one at a time, no matter how fast they come in, determines whether or not a race condition is present. So a race condition, what happens there is, and we'll bust out the whiteboard. So we have the, let me draw a better triangle. So this is going to be the program, the triangle, right? We'll put a little P in there. So what happens is we have two R's, right? Two requests. We're going to send the first request to the program, and the program is going to start to process this request. But while that's happening, we're sending a second request over within like milliseconds of this request being received. And what will happen is we'll do some lines here just to demonstrate layers. So request run is now here. So request one's right here, and milliseconds later we've now sent R1 over. So R1 is here, and then R1 goes here, and as R1 goes to here, R2 is now in the first stage, right? So what's gonna happen here is the requests are being processed at the same time, right? And so what that can lead to is multiple requests being processed for the same thing without like the checks going through or whatever needs to happen, right? And so we'll make it a little bit clearer here, right? So in this day, we're doing a bank, right? So here's the cache, right? And what we're doing is we're doing transfers from this cache reserve over to an account, right? So what we're gonna do is send a request or multiple requests for a transfer to an account, and these requests are going to come in within milliseconds of each other, and we're going to talk about this in a little bit. I'm just explaining how the race condition works for today. And essentially what we're going to do is send enough requests where it's going to transfer the money, but we don't have the amount of money in there, right? So let's say we have 1,000 in here. What we're going to do is we're going to send requests for 500, right? To transfer 500 from here over to here. So what we're gonna do is basically send multiple requests, right? Let's just say, for example, we're sending 5 requests to transfer 500, right? If the application was secure and it processed every request fully before processing the next request, we will only get our $1,000 in this account, right? So where the race condition lies is because those 5 requests are being received within milliseconds of each other, they're all going to get processed and then they're all going to complete, right? So at the end of those 5 requests, we're going to be left with negative 2,000 or 2,500 in the account, in the reserves, and then in here we're gonna have 2,500. So essentially what happened was, because the functions and the program didn't read every request fully, once the account does its account check to see if it can even send over the transfer, it doesn't matter because we're already sending more and more transfers over because all the requests are getting sent over, and then it does the check. And this will happen for as many requests as you send until the balance check hits 0. So we'll go back over to the day over here, and we'll take a look at HTTP2. So, I mean, this is an HTTP protocol. It's used for all the web applications that are out there right now. Most of them still use HTTP 1.1, but HTTP2 is a little faster and has better performance, and everyone's kind of slowly moving to it. The key difference is the web timing attacks between 1.1 and 2. It looks like 2 kind of fixes this issue where configured to better handle like web timing attacks like these, so that it's not as involved as 1.1. You have to go in there, configure it. It's not set by default. However, if you do implement it incorrectly, you can still see the same type of vulnerabilities in 1.1. Let's get into it. So what we're going to do is we're going to start up our burp suite here, and I already have it loaded up here. Cool. So what we're going to do is we're going to open up burp, go to the settings over here in the top left. And when that loads up, we're going to go over here to burp browser, and we're going to make sure that this option is checked, allow burp's browser to run without a sandbox. And then once that's checked, we can exit out of here. And then we're going to head over to proxy, make sure intercept is on. We're going to open up the browser. We're going to make sure that that's copied over. So when you start your VM, the IP is going to auto populate, so you don't have to worry about typing it out. Loads up. And before we actually start intercepting, I'm just going to turn this off for a second. We're just going to understand how the application works, right? This is always good to do when you're doing web app fuzzing, web app penetration testing, whatever it is. You just want to understand how the normal flow of the application actually is, and then try to look for gaps or holes or security misconfigurations or vulnerabilities in there based on what you want to do and what you want to achieve. So let's go ahead and log in. So we see it's a login screen, and this is our login here. So 110 and tester. We're going to log into the account. Boom. So you can see we have 1,000, and we can transfer to an account number and put the amount to transfer. So let's go ahead and do that. So they want us to send a transfer to 111 of 500. So what we're going to do, we're going to turn intercept back on, because we're going to be using the requests that are sent in this part, right? So we're going to do 111, and then we're going to send $500. So we're going to transfer, and then it's going to intercept over here in burp. You can see right here, this is what the post request looks like. So we'll go ahead and forward that, and then we get another one, we get the session ID. So let's go see what that looks like. Okay, forward it, and boom, you can see it was successful. We now have $500. So we'll go back over here, and you can see right here the slash transfer post is what we're looking at, which is what I was saying earlier. And we have the account number here, and we have the amount we're sending, right? And this is the request we're going to exploit. We're going to send multiple of these requests, and that's how we're going to exploit the race condition, right? And you guys will see here in just a few minutes. So we're going to be sending this to account 111. So what we're going to do is we're going to come over here. And don't worry if you don't see anything in here, it's fine. Burp always logs your history. You just got to go to HTTP history. We're going to look for the /transfer. And then we're going to right click, send to repeater. We're going to go over to repeater. And then what we're going to do is we're going to do Control R. And we're going to make 10 of these. So there we go. And now what we're going to do is we're going to make a group out of these. So we come over here to the hamburgers and we do create tab. And we're going to name it, we'll just name it group 1, right? And then we're going to select all our tabs. And the reason why we do this is because when they're in a group, we have these options. We can send the whole group at the same time, right? Which is what we want to do, because the computer can do this way faster than we can, right? Like we sat there and sent every single one of these. It would probably take us anywhere from, like, depending on how fast your computer is and your VM is, it would probably take you anywhere from, like, I would say 30 seconds to a minute if you're going like really fast. Maybe some people are taking even longer, and that's realistically too slow, right? Like the race condition probably wouldn't work because you're sending them so slow that it's able to process the requests before you send the next one. So that's why we're going to be putting it in a group here. And the option we're going to use here is send group in parallel last byte sync, right? And there's a couple other ones here. And the main difference between sequence and parallel here is the time it takes for it to send the requests, right? It really comes down to like milliseconds, not even less than milliseconds time difference. But for time's sake and the video's sake, just know that this one's faster. And that's why we're choosing this one, right? Because when it comes to race conditions, the faster you can send requests all at once, the more likelihood of success you will have exploiting the vulnerability. So that is what we're going to go with today. And let's make sure here. So what we're going to do is, here they're creating the group. All right, so now what we're going to do is we're going to verify the race condition works, right? So we're going to boom, we're going to hit that, send in parallel. Boom. All right, so it worked. So we're going to come over here to proxy, intercept, turn that off, and we're going to go back to our account. So we'll go ahead and refresh the page, and you can see our balance is now negative 4,500. The reason that is because we sent 10 requests sending $500 to account 111. We successfully exploited the race condition. We have the code here to see exactly how it works, right? They were nice enough to provide it. I'll hop over to the whiteboard to explain this guys for you, right? So in our case, we're transferring 500, right? And we have our 10 requests, so we'll do RX. So, and we'll do RY over here. And I'll just give you the example with 2 just because it's easier for me to draw. But, all right, so we send over request 1, right? Boom, we received request 1. And now we're here, right? In the first one, we're updating the recipient's balance. When R1 is here in this execute, then this one is received by the system again, right? So once R1 is here, R2 is now updating the recipient's account. So now, before our account has even been deducted 500, we are now updating the recipient's account to plus 500 and plus 500, which is essentially 1,000. So before we even get here, the recipient already has $1,000 in their account, right? And then R1, gets to this, they deduct the 500 from our account. Where the exploit lies here is every request is being sent within like millisecond, a hundredth of a millisecond within each other, right? So before this one's even ran on the first request, we could already have our 10 requests sent here updating the recipient's balance. And then because programming is start to finish every single time, every single request is then gonna go and update our balance, which is why we ended up with the -500, right? So essentially we sent more money than we had in our account, and because this application doesn't process one request start to finish before processing a second request, that is why the race condition lies. In a nutshell, that's how this all works. If you really want to dive more into race conditions, you can go on Google. There's probably a room on TryHackMe that you can set up, but we'll go back to how everything's working here. So all right, so now we got to get our flag, right? So we got to transfer 2,000 from the glitches account. So we understand the vulnerability. We need to assist glitch in validating it using the account number 101 and password. Glitch attempt to exploit that vulnerability by transferring over 2,000 from his account to the account number 111. So let's do that, right? So I'm just gonna close these all out and go back over to proxy, and we're gonna leave intercept off for now. We're gonna log out. We're gonna log into the glitch account, and here we are, glitch, and we are going to turn intercept back on, and we're going to send a request from glitch account. So target account is 111. I'm going to send 1,000. Oh, 10,000, pretty crazy. Transfer, and we've got the request here, so I'm going to send this over to repeater. And then we're going to Control R, all of that. And you really don't need this many. Realistically, you could just do 3. And then we're going to create a tab group. Yeah, sure, we'll call it get all those in there. We're going to change this to send in parallel, and then we're going to click that. So let's see if it worked. We got to go turn intercept off. Got insufficient funds, and boom, we got the flag, right? So here's the flag. Pretty straightforward day, to be honest. Yeah, and you can see here they do have a room. It's linked at the bottom here, so you can go do that. And that's pretty much everything, guys. Here they do tell us how to fix race conditions, so we'll go through that. So we can see that it didn't properly handle concurrent requests, and this led to the race condition vulnerability, which is what I was talking about earlier. So when multiple requests were sent in parallel, each deducting and transferring funds, the application processed them simultaneously without ensuring proper synchronization. This resulted in inconsistent account balances, such as negative balances in the sender's account and excess funds in the recipient account. So the first thing they recommend for fix atomic transactions. So the developer should have implemented an atomic database. So they could have implemented an atomic database to ensure that all steps of the fund transfer are performed as a single unit. This would ensure that either all steps of the transaction succeed or none do, preventing partial updates that could lead to an inconsistent state. So what this means is, when we go back to the code, right, it's pretty much saying, like, instead of having the commit here in the middle, we could just have this last one, right? So it's going to update the receiver's account and deduct our balance before we commit to the database. Therefore, every time it's done, we're deducting and sending at the same time. That way everything kind of stays in sync, and we're not like doing this and then doing this. And then we can implement mutex locks. So they could have ensured that only one thread accesses the shared resource, such as account balance, at a time. This would prevent multiple requests from interfering with each other during concurrent transactions. So essentially, we could send multiple requests, but only one request is able to access the database to update the account, the sender account, and the recipient account at a time. So therefore, it's basically what I was saying, it's letting each request finish start to end before processing the next one, which would avoid it, because after the first or second one, we wouldn't have enough funds to continue processing all the requests, and the rest would just get rejected. And then we can also apply rate limits. So the developer could implement rate limiting on funds transfers and withdrawals, and this would limit the number of requests processed within a specific time frame, reducing the risk of abuse through rapid repeated requests. So this one's basically saying, hey, only process one request in this amount of time. No matter if you receive multiple requests, we're always going to do this in this amount of time regardless. Yeah guys, if you enjoyed this video, feel free to share it with someone. If you just liked the video, feel free to leave a like, and if you want to keep following along, hit the subscribe button, helps me out. But that's it for the day. I'll see you guys in day 13. Wish you guys all the best and Happy New Year.